Alright, so we're going to start looking at examples of the average rate of change. The first thing we're going to do is look at an example that has a graph. So we're going to start with the x and the f of x axis. And let's go ahead and make this 1, 2, 3, 4, 5. And let's label the x-axis as well. So let's do 1, 2, 3, 4, and 5. Why not? Alright, so we're going to have 2 points of this. Let's start at 0, 5. And let's also have a point at, let's say, 4, 3. Now, when we're making this shape, let's go ahead and make it look kind of like a quadratic or a parabola. So we'll dip on down until we hit about 2 and then come back up to 4, 3. Now, let's say that we wanted to find the average rate of change between these 2 points, which would be the slope of that secant line. So find average rate of change. So remember that the average rate of change is going to be f of b minus f of a divided by b minus a. Now, this is the same thing, actually, as y2 minus y1 over x2 minus x1. So if you have 2 points, you're going to subtract the y's and divide it by the x's subtracted. So in our case, what that's going to be is 3 minus 5, so the 2 y points, subtracted by 4 minus 0. Now you want to make sure that the y's and the x's stay in the same order. That means that 3 is going to be above 4 and 5 is going to be above 0. So when we do that, we're going to get negative 2/4, which is going to give us an average rate of change of negative 1/2. Now, before we move on to the next example, I just want to point out one more thing, which is that the above part is actually familiar to us. What that is that's the net change, which is the difference in the y values. So that's net change, which we can find here. Also, if they asked us to find that at the beginning of the problem, it would have just been the top part of that fraction, or 3 minus 5, which is negative 2, would have been the net change. All right, let's go ahead and look at another example. Okay, so for this example, let's actually look at when we have a function. Let's look at h of t equals negative t plus 6 over 5, so 6/5. And let's do this between t equals, let's say, negative 6 and t equals 4, so positive 4. Now for this question, before we go ahead and find the average rate of change, let's start by finding the net change. So the net change is going to be h of 4 minus h of negative 6. So it's always going to be the bigger number minus the smaller number. So in this case, we're going to take 4 and plug it in for t, so that's going to give us negative 4 plus 6 over 5 minus, now we have to figure out what h of negative 6 is, so we have to plug negative 6 in for t. Now notice that I wrote a negative 6 right there. I actually meant to write a positive 6 because negative would make that positive. So we're going to have negative 4 plus 6/5. Then when we distribute that negative, it's going to give negative 6/5. Those 6/5 are going to cancel out. And then we're going to have negative 4 minus 6. Remember, it's supposed to be a negative 6. So when we do that, there we go, fixing that problem, we are going to get negative 10 for our net change. Now, next what we're going to do is find the average rate of change, so the AROC. Now when we write this formula down, notice something, which is that the top part, h of 4 minus h of negative 6, is the net change that we just found in the top part. So it's divided by 4 minus negative 6. So that top part is actually the net change that we just found. So we can just replace that with the negative 10. We don't have to do it again. So we're going to have negative 10 divided by that bottom part, which would be 4 plus 6, which is just 10. So negative 10 divided by 10 is going to give us a negative 1 for our answer. Great. Let's go ahead and look at one more example where instead of looking at a interval with two numbers, let's look at one where we have an interval that has a variable in it. So for this example, let's go ahead and look at, let's say f of t equals 7t squared. And let's look at that on the interval from 2 to 2 plus h. So we're going to be some distance h away from 2. Whoops. Just get rid of that. H. All right, so if we want to find the average rate of change, well, that 2 is going to be our A, and the 2 plus h, that's our B. That whole thing is our B. So our average rate of change in this case would be f of B minus f of A divided by B minus A. So that's the definition. Now, when we plug this in, we're going to have f of 2 plus h minus f of 2, minus f of 2 divided by, now remember on the bottom we have B, which is 2 plus h, minus A, which is 2. When we take that 2 plus h and we plug it into our function, what we are going to get is 7 times 2 plus h squared minus, so we have to take 2 and plug it into there, so that's going to give us 7 times 2 squared, all divided by, now on the bottom I have the 2 and the negative 2. Those are going to cancel out, so I'll just have an h left. Now when I expand the top, that's going to expand to 28 plus 28h plus 7h squared minus 28, all divided by h. Now this is the fun part, is where we get to cancel some things out. So the 28's cancel. That h is going to cancel with one h on each of these terms on the top, so that h is going to go away. One of those is going to go away in the bottom. So what we are going to be left with is 28 plus 7h. And that will be our final answer.